In this lesson, we're going to look at the particle model for temperature. Now, the first thing we're going to say is that the temperature of a substance is directly proportional to the average kinetic energy of its particles. And this is true whether the substance is a solid, whether it's a liquid, or whether it's a gas. So in the case of a solid, the particles are vibrating constantly, and if we were to increase the temperature of that solid, the average kinetic energy of the particles would increase. Likewise with a solid, likewise with a liquid or a gas, these particles are free to move, and therefore as we increase the temperature, the speed of these particles will increase, and as a result the average kinetic energy of the particles will also increase. So as you increase the average kinetic energy of the particles, the temperature increases. As you decrease the average kinetic energy, their temperature decreases. The next thing I want to look at is the unit for temperature. Temperature traditionally has been measured using something called the Celsius scale, and Celsius was the name of the scientist that defined the scale. And he defined this scale arbitrarily using water as his reference point. That is to say, he took the melting point or freezing point of water and he defined that as 0 degrees on his scale. So that became known as 0 degrees Celsius. And then he took the boiling point of water and defined that on his scale as 100 degrees Celsius. So you've got the two marker points now to define your scale. You divide it into 100 intervals, and you've got a neat way of measuring the temperature. If you want to get colder than 0 degrees Celsius, which is often the case, particularly if you live in Britain during the winter, then you choose a negative number to measure the temperature. But Celsius lived a long time before anybody knew anything about particles or kinetic energy of particles or average kinetic energy of particles, for example. So later on, scientists realized that the temperature is a measure of the average kinetic energy of the particles. Then that implies that there must be a temperature at which the particles have 0 kinetic energy. That's to say, when the particles stop moving altogether. And this temperature is known as absolute zero. That's to say, that's the temperature when all movement stops. And we say there is 0 kinetic energy of the particles. So, whereas Celsius's 0 was arbitrarily chosen, Kelvin, on the Kelvin scale, 0 meant 0 kinetic energy. And this absolute 0 occurs at a temperature on the Celsius scale of minus 273 degrees Celsius. Okay, so we'll define absolute 0 down here when there's no movement, and we'll define that as 0 Kelvin. Notice it's just a K, not degrees Kelvin. And this temperature occurred on the Celsius scale of minus 273 degrees Celsius. So on the Kelvin scale, the melting point of ice, or freezing point of water, occurs at 273 degrees Kelvin, whereas the boiling point of water occurs at 373 degrees Kelvin. Okay, so in fact there isn't really much difference between the Celsius scale and the Kelvin scale. The intervals are exactly the same. So a change in temperature, notice a change in temperature of say 25 degrees Celsius is the same as a change in temperature of 25 degrees Kelvin, because the intervals are the same. All we've done is shifted the position of the 0 on the scale. Celsius's was arbitrarily defined, whereas Kelvin's more precisely is defined as the temperature at which all movement stops. I'd just like to go back to this initial statement where we said that the temperature of a substance is directly proportional to the average kinetic energy of its particles. What we mean by that is this. Supposing we have a graph with the temperature in Kelvin along the horizontal axis and the vertical axis, we have the average kinetic energy of the particles in a gas, for example. And by saying that the average kinetic energy of the particles is directly proportional to the temperature, we have a linear relationship. That means a straight line graph. Now that linear relationship means, for example, if I were to double the temperature in degrees Kelvin, not in degrees Celsius, then that means we double the average kinetic energy of the particles. Or, for example, if we halve the temperature in Kelvin, we halve the average kinetic energy of the particles. Or if we triple the temperature in Kelvin, then we triple the average kinetic energy of the particles. Okay,